In today's lectures, we are going to discuss about pipeline conflicts. What are the various type of conflicts that exist in the pipeline that we are going to discuss today, right? In the earlier section, we have already discussed what is pipeline, how many types of pipelines are there. Now, today we are discussing about pipeline conflicts, right? So, what does the word conflict means? Means, see, conflicts is something which is associated with the performance of a pipeline. Conflicts means degrading the performance of pipeline. All those causes which is actually responsible for degrading the performance of pipeline, that it means by conflicts. So pipelining conflicts, we are going to see what are the various types of causes which is actually responsible, for degrading the performance of pipeline. So there are some factors that causes the pipeline to deviate its normal path. So we have certain reasons why the pipelines get deviated from the path which normal performance which it used to get, So whatever it used to perform, once what are the reasons, what are the reasons that makes the pipeline to deviate from its normal performance, which degrades its performance? That is something that we are going to discuss, right? Some of these factors are given below. So now we are going to see what all those factors are responsible for degrading the performance or deviating the normal performance of a pipeline. See, first conflict or first factor that is responsible for degrading the performance of pipeline is timing variation. Now we'll understand what is timing variation. हम समझेंगे कि timing variations होता क्या है, right? See, all the stages cannot take same amount of time. We know we have different types of stages, as we have already discussed in our example of packaging of a bottle. First, what happens? First, the bottle is being put. After that, it has been refilled with the water, and after that, it has been sealed. So three stages are involved. So practically, is it possible that all the stages take the same amount of time to finish their job? Is it possible? See, I am giving an example. हमने जैसे मैंने आपको पहले एग्जाम्पल में समझाया था, something that I have already mentioned you in the prior example. हमने पैकेजिंग ऑफ बॉटल का एग्जाम्पल लिया था. We have taken that example. In that example, what was the stage first? Inserting the bottle, then filling the bottle, then sealing the bottle. So these were the three stages. Now, inserting the bottle and filling it with the water and then sealing the bottle, is it practically possible that they all three stages take the same time? No, obviously it's different proportion of time is being taken by the different stages. So what they trying to say that all the stages cannot take same amount of time. That's right, it's practically not possible. So this problem generally occurs in instruction process. कहाँ exist करती है इस तरह की problem? This is the problem which is actually very frequently take place in whenever we do the processing of instructions, right? So where the different instructions have different operand requirement, we know that different instructions have different operand requirement. Some instruction needs some other operand, other needs some other. So different type of instructions require different type of operand. अलग अलग instructions को अलग अलग operands की जरूरत पड़ती है, and thus different processing time. एंड ऑब्वियसली जब इंस्ट्रक्शंस अलग अलग इंस्ट्रक्शंस हैं, उनके अलग अलग ऑपरेंड्स की रिक्वायरमेंट है, तो उनका प्रोसेसिंग टाइम भी डिफरेंट होगा, ऑब्वियसली, राइट? गेटिंग माय पॉइंट? So what is the summary of this point? The summary of this point is that it's practically not possible that all the stages that are involved in the pipeline take same amount of time. Time differ from stage to stage, right? And especially in the case of instruction processing, where the instruction required different type of operand, right? And that different operands require different processing time. हमारे instructions को अलग अलग operands की जरूरत होती है और हर अलग अलग operand अपना अलग अलग processing time लेता है, right? So this is the first factor that is responsible for degrading the pipeline. Now second factor is data hazard, right? Now we'll understand what does this word data hazard means. हम समझेंगे data hazard का मतलब क्या है. See, when the several instructions are in partial execution and if they reference same data, then the problem arises. What these people are trying to say that there are different type of instructions. Suppose, there we have two type of execution. First is fully execution, second is partial. तो पूरी execution हो ना, partial मतलब थोड़ा ही part execute करना. तो उस केस में क्या होता है? What exactly is happening at that case? If they reference same data, then the problem arises. A partial certain instructions are there and we have to do certain execution of that instruction, and that's too partial. राइट, हमें उसका सेट ऑफ इंस्ट्रक्शंस का पार्शियल एग्जीक्यूशन करना है, तो हम जानते हैं व्हाट वी नो, इफ दे रेफरेंस सेम डेटा, सपोज इंस्ट्रक्शंस डिफरेंट डिफरेंट इंस्ट्रक्शंस, वो सभी एक ही डेटा को रेफरेंस कर रहे हैं, तो इस तरह की प्रॉब्लम आएगी. सो वी मस्ट इंश्योर द नेक्स्ट इंस्ट्रक्शन डज नॉट अटेम्प्ट टू एक्सेस द डेटा बिफोर द करंट इंस्ट्रक्शन. तो हमें इसके लिए क्या करना होता है, हमें इंश्योर करना होता है, वी हैव टू मेक श्योर दैट the instruction that is coming soon after it, or the instruction following the first instruction, does not attempt or does not try to access the data before the current instructions. Means until unless that instruction is being used by the first, are you getting my point? Until unless the data is being used by the first instructions, we make sure that the second instruction does not try to access it, does not try to take it, right? Because this will lead to the incorrect results. Because if the two instructions simultaneously will try to take the same data, is it practically possible? Definitely not, right? So obviously some incorrect result will be displayed. So in this case of data hazard, we have to make sure that the several instructions are partially executed. Whenever certain instructions are there, whenever the fully execution of that instruction is not taking place, जब भी किसी भी इंस्ट्रक्शन का फुली इंस्ट्रक्शन नहीं हो रहा है, पार्शियल एग्जीक्यूशन हो रहा है, और वो सभी इंस्ट्रक्शंस क्या है, रेफर कर रहे हैं सेम डेटा को, तो हमारी डेटा हजार्ड की प्रॉब्लम एग्जिस्ट करती है. और इस प्रॉब्लम को ओवरकम करने के लिए, इन ऑर्डर टू ओवरकम दैट प्रॉब्लम, व्हाट वी नीड टू डू, वी नीड टू मेक श्योर दैट the instruction which is just following, which is coming soon after the first instruction, does not try or does not attempt to access the data before the current instructions. The current instruction which is actually using that data, we have to make sure the second instruction does not try to take that data from the first instructions. So why we are doing so? Because by doing so, the incorrect result will be displayed. जो है हमारा गलत result display हो जाएगा. Now the third factor that is responsible for the degrading the pipelining is branching. अब हम समझेंगे what is branching. See, in order to fetch and execute next instruction, we must know what that instruction is, right? And if the present instruction is conditional branch, it will lead us to the next instruction. See, it's very important कि भाई हमें कुछ भी data fetch करना है, तो instruction fetch करना है और execute करना है. In order to fetch and execute the next instruction, हमें क्या पता होना चाहिए, what that instruction is. भाई हमें ये पता ही नहीं होगा कि वो instruction क्या है, तो हम उसे fetch कर सकते हैं. Is it practically possible that until we are not aware of what that instruction is all about, can we fetch that or execute that instruction? No, it's not possible. So it's really important that we should know, we should have information about the instruction that we need to fetch. And along with that, simultaneously, the present instruction, are you getting my point? जो हमारा present instruction है is a conditional branch and it result will lead us to the next instruction. यदि हमारा जो present instruction है, if the present instruction is a conditional branch, right? जो हमारा current running instruction है, यदि वो conditional branch है, तो result will lead us to the next instructions, right? So then the next instruction may not be known until the current one is processed. और जब तक हमारा first जो instruction है, वो process हो रहा है, तब तक हम क्या है, करंट इंस्ट्रक्शन जो फैच हो रहा है, जो रन कर रहा है, उसके बारे में हमें कोई इन्फॉर्मेशन नहीं मिल सकती. तो व्हाट दे आर ट्राइंग टू से, द प्रॉब्लम ऑफ ब्रांचिंग इज दैट in order to execute any instruction, it's really important that you should know, in order to execute the second instruction, it's important to know the first instruction. Until the first instruction is not known, we'll not be able to fetch the second instructions. And if the present instruction, that is the first instruction, is a conditional branch, यदि वो conditionally branched है, then the result will automatically lead us to the next instructions. And we may not be know that what instruction that second instruction is all about. भाई जब तक हमारा पहला प्रोसेस हो रहा है, तब तक हम सेकंड इंस्ट्रक्शन के बारे में नहीं जान सकते, राइट? और सेकंड इंस्ट्रक्शंस को फैच करने के लिए, एग्जीक्यूट करने के लिए हमें उस इंस्ट्रक्शन का जानना बहुत जरूरी है. So this is what the problem is all about, and this problem is termed as branching, right? Now the fourth problem that comes into the pipelining, or which degrade the performance of pipelining, is interrupts. Now I'm sure you all are very much familiar of interrupts because we have already taken the interrupt this topic independently and in a very detailed. आप सब समझते हैं what exactly the interrupt is, क्योंकि हमने इसे पूरा डिटेल में पढ़ चुके हैं. So let's take this point, interrupts. interrupts set unwanted instructions into the instruction stream. अब interrupts क्या होते हैं? हम जानते हैं interrupt हम क्यों create करते थे? Why we used to create the interrupt? In order to take the CPU to run whatever job the CPU is running, you know, at current, if we create an interrupt, then that current job will be paused and CPU will get the time of the CPU will gain by the interrupt or by the job which actually creates the interrupt. भाई सीपीयू के टाइम को लेने के लिए तो हम इंटरप्ट करते थे. उस केस में क्या होता है कि वट एवर द जॉब इज रनिंग, जो भी जॉब रन हो रहा है उसको इंटरप्ट, वो सीपीयू वो हॉल्ट हो जाएगा और सीपीयू का टाइम हम जो दूसरा जॉब जो इंटरप्ट क्रिएट कर रहा है उसको मिल जाएगा. So what they are trying to say is that interrupt sets unwanted instruction into the instruction scene. Interrupt से क्या होता है कि unwanted instructions आ जाता है instruction scene में, and interrupt affects the execution of instruction. Definitely हम किसी भी चीज को करंटली कोई भी चीज जॉब वर्क कर रही है उसमें यदि हम इंटरप्ट करेंगे तो ऑब्वियसली जो इंस्ट्रक्शन स्ट्रीम है उसमें एक एडिशनल इंस्ट्रक्शन आ जाएगा विच इज नॉट रिक्वायर्ड. उससे क्या होगा? द एग्जीक्यूशन ऑफ द इंस्ट्रक्शन विल बी अफेक्टेड, राइट. And last but not the least, data dependency. Now we'll see what is data dependency. It arises when instructions depends upon the result of a previous instructions, but this result is not yet available. Data dependency means when one data depending on the other one. This is termed as data dependency. When the execution of a result of one data depends on the execution of other data, for example. And so data dependency means depending on someone. So it arises when instructions depends upon the result. अब ये कब एग्जिस्ट करता है, कब अराइज करता है? जब भी कोई इंस्ट्रक्शंस डिपेंड करता है किस पे? रिजल्ट ऑफ द प्रीवियस इंस्ट्रक्शंस को. तो उस तरह की डिपेंडेंसी को हम डेटा डिपेंडेंसी कहते हैं. बट दिस रिजल्ट इज नॉट येट अवेलेबल, और ये रिजल्ट हमारे लिए अवेलेबल नहीं होता है. So these are the various we have seen what are the flaws or what are the various types or what are the various conflicts that exist in the pipeline, right? What are the factors that actually degrades the performance of pipeline? This we have seen. We have seen timing variations, data hazard, then we have seen branching, we have understood interrupts, and in the end we have understood data dependency, right? I think that is all for today. If you still have any problem, please feel free to ask me. Thank you so very much.